Okay, so I had to cut the previous video because we had some, kind of over complex logic just to limit the agent's velocity for the AI. So let's make it a lot more simpler. So after we set the destination, as we do here, let's take the velocity and we're going to say, well, we're just going to clamp it. First of all, on the Z, clamp. Okay, so here's what I've actually came up with. I want to try this first. So we're taking the velocity, then we say we're going to clamp it. Then we're simply going to change this over here. Though, keep in mind that this will still not pass over the speed we have over here. And let's set acceleration to 9999. Okay. So basically all of this is just to set up, because we don't want him to move the same speed going up with the same speed going left and right. Okay, so I think we only have to solve on the Z, and just to control this from the agent itself, we're simply going to say, you know what, let's make, maybe let's call this vertical speed, where we're going to do a get. Then we're going to have the agent or the unit controller.agent.speed minus point to f, or let's try with 1f, or maybe even half, I guess, and return .p. So we can do minus vertical speed and vertical speed. So we clamp the z value for this. Okay, closing that. And do say, let's maybe do 0.35 for speed. Yeah, that's fine. That's pretty good. But attack distance should change right now. And I think that's actually fine as well. So what I'm going to do is actually add some, oh, first of all, we need to change the rotation to this. So we're going to do if mathf dot unit controller, actually mathf dot amps unit controller dot agent dot velocity, or the velocity we have above, since we already do that, is greater than 0.2 f. So we have some values there. Then I'm going to say v dot x is lower than 0. Save that. So that should fix the little jerking it's going on. Okay, so that's actually perfect. We just need to add some dead time for him so that he's not actually doing anything, or either he should not be doing anything, or from the attack, I guess. So let's say we have some float dead time, and let's do public float mean dead time max dead time, and we're going to play, going to do random.range from min dead time to max dead time and return value. Okay, so if dead time over 0, dead time minus time dot delta time. Don't think we're using delta time anywhere else. We do, okay. So that's the perfect time then to do this. So minus delta, minus delta over here, and minus delta. So if the time, then return, then dead time will happen after you attack once. Play action, okay, so dead time, let's say get dead time rate. And let's make it from half a second to up to a second. For now, that should work. Let's see. Okay, so now they're not rushing you. They're doing something. Yeah. Okay, so the distance to the attack distance probably needs to be lower. Let's see the target position we have. The target position, direction to target, the opposite by attack distance. Okay, the Z to be 0. So let's do debug draw ray from on the target position. Let's do vector 3, and actually let's do vector 3 dot up by 20, so it's up, actually not, let's just do this, color dot red, and let's make it go forward so we see it. So we're actually now be able to see where the target position is. Technically we should be able to. Yeah, we see it over there, so he should be going there to attack. Or yeah, here's the thing, he's actually checking the attack distance from this and not from this. So the distance we need to be checking, vector 3 distance check, actually no, you know what, we will say distance attack distance if it's closer than the attack distance. Target position. So I think I'm going to make the attack distance, or we're going to separate this, and let's say unit controller dot agent dot stopping distance. And let's set stopping distance to something like maybe 0.1. So now we shall see him go to the actual position, not based on the target position. Okay, so now you can see that this is kind of better, but still not good enough. Let's do 0.4. Yeah, 0.4 is much more accurate. Okay, then attack distance, if I say 0.5, he's going to go over there. So that's something we can actually play with, because we could have an enemy that, depending on the attack he's going to do, he will change his attack distance. So you can have him go here and then rush to the player, something like that. Okay, that's all things we can do. Of course, for bosses maybe it makes a little bit more sense. for this guy, let's say maybe 0.3 is fine, and I'll say even 0.5 is fine because his attack has a reach. Yeah, 0.5 seems more than fine. We just need to have a check now if the distance is closer than yeah, so if we're basically close to the enemy, don't do this, don't go back. So let's have another check. Float distance to enemy. And now vector 3 dot distance transfer position to the target dot position, which is the enemy. Let's maybe rename this to enemy position. However, we should check, we should eliminate the Z, I believe, the Z value to this. So we're only checking the X positions. So let's encapsulate both of these into a single bool. So let's do bool. Let's make it public because we might want to access it. Is close to target position, vector 3 position 1, vector 3 position 2, and right now let's just do vector 3 as this target position. So position 1, position 2, and return this. Okay, so this now should be here. Then we can delete this, target position, and we're going to say target transfer dot position to target position. Okay, then we need to check the distance to enemy, and let's do public bool is close to enemy, vector 3.1, vector 3.2. Then we're going to eliminate Z. So, but actually let's do float difference p1.z minus p2.z, and if difference, or if mathf.abs difference on the z is lower than, let's say 0.2, then we are actually close. Okay, else if you're not close enough to attack, so simply do a return. Then we're going to do, then we can actually just check the distance between the two of them is less than attack distance. Let's do it like this. Okay, so it's close to target or is close to enemy, then transform dot position and enemy dot position. Okay, so what this is going to do is basically check if you're close to the enemy and if you're close to target position. So if you're closer to the enemy than your target position, without taking account the Z of its value, the Z, so the depth, then he's going to actually attack him. And now it's not working because we do not have an enemy assigned. Okay, so he should attack and he should continue attacking after the dead time. Okay, until I leave, where he's just going to keep attacking. Okay, so 0.2 is not close enough for him to attack, so we need to control this somehow. Let's call this public float vertical offset or vertical threshold. Let's maybe make it point 1. Okay, maybe 0.1 is too much. Let's go by half. Yeah, I think that's fine. Huh? Maybe not. Yeah, the stopping distance is too slow. So let's maybe do this 0.5 as we said before. Stopping distance 0.5. And let's hit play. Let's see how he is going to behave now. Okay. Then he should be able to attack us. No. He's not doing it. Okay, let's change the mean dead time to 0 and 0. Okay. Something is wrong here. Not so sure what it is, however. Let's try this. Maybe the stopping distance is too much. That seems to work now. Apart from he's not attacking. The time is at -0, attack time 5. Let's put a breakpoint actually, and let's see why this is failing. So in here, let's go in here and we're going to say distance is greater than 0.49 and stopping distance is 0.5. So let's see what this returns. We are in. Oh, we actually want the opposite. Yeah, okay. Or. No, we actually do not want this. This needs to be false. And let's see. Yeah, okay, so this should not be if you're not close to target and not close to enemy. I think that would be. Let's actually make this is close to target position just so that it's easier for us to see and to read. And then bull is close to enemy. So if you're not close to the enemy and you're not close to target, I think that should be it. So if you're not there, then just go here. Otherwise, whatever it is, just attack. That seems more correct, but we'll see, of course, on the test. Well, that failed. Now he never. Come on. Distance. So this needs to be. This is actually the opposite. Let's play. Yep, that's what we want. Perfect. Um, that actually didn't work. But I'm not sure which one is actually triggering it. So let's make this public variables. Just so that we can see them. There is no need for them to be public, but I want to see which one is doing the call of this case. Okay, so this one now says it's close to enemy, so that one is failing. So because the attack distance is closer than 0.4, so then the vertical threshold, I'll set it lower than it can ever be. Yeah, that actually works fine. That actually works perfect. Okay, so I think that's it. We could even do even smaller. Let's say even half of that. So he gets closer and closer and closer. Now, because we are on pixel level and these are using pixel unit about 100, we can actually use values like this so they matter. If I want to say you're only going to be able to be from 1 pixel farther away, that will mean he will only calculate 1 pixel from his position. Otherwise he won't be attacking, but actually that kind of work. It worked because the stopping distance for the player is even higher. Now he should be pixel perfect every time before he attacks. Yeah. Okay. Now I don't think pixel perfect is the trick, but you can see that you can get pixel perfect results at least. Okay, you can notice this because they are aligned. And I think we should fix a little bit our own speed as well. Okay, so let's recoup. Vertical threshold, let's make it about 3 pixels or maybe 5 pixels width. And stopping distance, we're going to make it again like maybe 5 pixels width as well. Attack distance can stay at 0.4. And because we have a threshold on the rotation, we can actually control the threshold we have for the rotation. Let's do this here. Public command, public float, rotation threshold, and let's just give it 0.5 maybe. So he's actually moving without turning his back to us. He's going backwards without turning his back. So that will be it for this part, which is a continuation from the previous part, of course. And okay, so going down, even going forward, you can see that he's not going to turn back to us. He's just going to go backward, which is perfect. Perfect, perfect, perfect. Okay, awesome. So let's end this part here. And this will work, of course, with two enemies, but I'm going to duplicate this guy. So we don't have to worry about changing the different scripts we have, changing their values. But this guy now has an issue. Okay, maybe 0.5 is too much. Let's maybe do 0.3. I think it has to do because we are using the yeah, okay. We're using the velocity to handle the rotation. X. Yeah, okay, you know what? Let's do unit control dot agent of velocity, or let's just use the velocity to this. Well, I can actually just check this before we set up that. And instead of, let's say agent the desired velocity. So it's more raw. Yeah, okay, that works better, I think. Maybe not. And here's something we have to solve as well. They kind of collide with each other, so that's another problem we need to fix. Yeah, that will break a lot of their behaviors, but we can fix that by basically not sending everyone at once and on the same position. So let's fix the rotation at least. Rotation, velocity, velocity. Let's maybe use the actual velocity. This kind of needs a little bit of digging around, you know, to see which one we should be using. Let's do 0.3 for all of them. Okay, so 0.3 didn't work for this guy. Let's do 0.1. And yeah, I saw one thing we're using wrong. Oh no, we're using velocity. Yeah, I'm not crazy about it. You know what? I think we can actually solve this a little bit better. And that will be if you're not close to the enemy, then change your velocity. Yeah, let's do that. If you're not close to the enemy, then change velocity. Change your rotation based on the velocity. Otherwise, if you are close to the enemy, then simply never look the other way. So that will mean always look the opposite of your enemy. So look left. This is target. Okay. Let's maybe change this to unit controller then. He's looking left. Enemy position. Let's create a shortcut. So we don't have to change our code all the time. Okay, so this needs to be the opposite. Let's try it. We might have to change a little bit the distance. Yeah, we might have to change the distance we are in. Yeah, I think we have to do that. Yeah, we do. Okay, so let's do another distance check. Is close to enemy. Let's rename this to is close to enemy. No vertical. Public bool is close to enemy general. And we're simply going to return this, and let's create another definition. And let's call this rotate distance. Okay, so bool is close enemy general. Let's actually delete these two and add them in here again. Close to enemy, no vertical. Transfer the position with enemy dot position. Now there's a shortcut we can use because we're using a lot of our own transfer dot position. We can say my position and save it here. It's going to be a tiny micro optimization, but we can use it. Okay, because our position will never actually change in this frame. And the enemy position, we can do the same thing for the enemy position. Because in a single frame, those never change, so we don't have to be calling the transform every time we want to know one of our positions. Okay, let's see. Okay, I think that's fine for now. Okay, so is close to enemy in general. We just replace this. So if he's lower than 2, he's never going to be changing his rotation. Man, that is way too much. And actually, you see that because we are using the opposite, we shouldn't be doing that. We should be doing not the opposite of the player. We should be doing the depending on the direction to target. Yeah, direction to target of text. If it's lower than 0, then that means left. If it's higher than 0, then that means right. Let's see. Perfect. And we can even go even higher than I believe. Okay, let's try and fix them clipping on each other. And the way to do that will be after we set destination, we can do navmesh hit. And let's do it over here. Oops, what's this? .ai, okay. So after we have set our destination, after we have set our velocity, we're going to do navmesh hit or nav hit. We don't need to set that up, but we can say navmesh dot recast from our own position to the agent. That works as a distance. I don't know if this works as a line cast because it says source position, target position. Well, we'll see. Then unit controller dot agent dot desired velocity out nav hit. Okay. Let's see what we're missing. Oh, the areas. Navmesh dot all areas. Okay. So if nav hit, is this used as a bool? Okay. So if we hit something, I think we need a solution of it. And if we hit something, actually stop our agent. This stopped equals false, equals true. And because I want to know what I'm actually hitting and I don't want to hit my own collider, I'm going to say navmesh hit dot position distance. Yeah, okay. We don't know what we're hitting though. That's a bit of a problem. Position, normal, mask. Yeah, we don't know what we're hitting, so let's just say we stop him and we will see. Yeah, so these guys are actually hitting themselves. But I'm not sure how this actually will work though. So let's see now. It's a little bit of a stupid way this works. And it's starting to become that the nav mesh is actually more problematic than solving most of the issues we have. So that's a little bit annoying. Okay, for now let's keep it, but I think we might want to go and change how this works. So let's think. Now let's hit recast. Yeah, I think we just need to remove this entirely. And you know what? Let's actually remove the nav mesh on the next part. Well, actually, no. I'm going to think about it. We'll see if we want to remove it or not, because we can simplify this a lot more if we use a different navmesh. Okay, and of course when they are dead we should be closing the navmesh agent. Actually, if we let's see. Let's think. We should somehow solve them getting close to other units. So when they are here, they don't behave like this. But when they are here, they should be doing something else. So you know what? There's one way to do this. We could be using... Actually, let's solve that on the next part. Or you know what? Let's try something now. We'll see if we should be... Yeah, okay. So let's do colliders physics dot spherecast, actually overlap sphere, transfer dot position and radius, let's say the same as the rotate distance. Now I'm just hard coding a value. So for each colliders we're having over there, if we have a unit controller onto them, transfer dot get component in parent unit controller, if unit is not null, if unit dot is unit dot team is the same as my unit controller dot team, then we're making stop public. So bool force stop equals false, force stop equals true. And you know what? Let's make this a public bool. Force stop. So we're going to say if unit controller dot force. Oh, we actually need the AI handler. So let's set directly for the AI handler because we won't need it for the other players. AI handler. If there is an AI handler, then that means he's an AI, so we don't have to stop him. So if a dot force stop, if he's not force stop, the other AI, then we're going to give him the right of way, and then we're going to force stop. So we're going to say n not force stop here. So else if force stop, actually under rotation we should be checking if is close to target position, if is close to enemy in general. We'll do this. Actually, let's leave this because we are complicating this. So if you are force stopping, maybe let's say if force stop, do not do the attack. That's one way to solve it. The other way would be to create a new path, which actually won't be that hard to do, but we will see if we want to do it like that. Yeah, one thing we need to change as well is if A is not this, otherwise you're hitting your own position and saying that you want to stop, and it's you that's actually stopping you. I don't know why this guy stopped, but maybe he did. You can see that he's, let's see, this guy is for stop. I don't know why. Now he's always for stop. Not why not. That's maybe too much. Yeah, I'm not crazy about it. That it works. Maybe we change this to 0.1f. We can of course make this a public variable. And yeah, you can see that this actually works fine. The other one, it should be the opposite. It should be if you're not for stop. Let's say you are forcing him to stop. If we're not force stopped. But we don't. This way, we might always be force stopped though. I think this way they will be forced. Or well, they never get forced stopped. Oh, that actually kind of does something. And what I do is that, okay. Let's try one more thing. Let's say that this now is going to be a public variable. Let's point 2.3. Cost of distance, okay. With that, let's try it out. Yeah, okay, force stop doesn't do anything right now because of course we are changing that. So let's change our own force stop. That kind of works a little bit better most of the time. Yeah, that actually works fine. That works as a behavior. Not that bad. It's actually doing it like one hits first. Mm. I'm not too crazy about it. But let's say we keep this for now and we'll see what we're going to do about it later. It's working, it's not perfect, but it's going to have to do for this because we are close to an hour. So that's it for this part. As always, you know what to do, like, subscribe, and if you like to see more stuff, more videos, more series, more of everything, of course, continue supporting me so we can make all of this. I'll see you on the next one.